Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. Most of us understand object-oriented programming to some degree. We might even have a deep understanding of design patterns, refactoring, and testing. However, a lot of those understandings can fall abruptly to the wayside when you're writing code on a large team with dozens of other developers. In this episode, we're going to discuss some of the things that can happen when you try to do object-oriented programming on a large team and how things can go wrong. We'll also talk about some workarounds. But before we get started, Will, what have you been fighting this week?
Well, we finally got to do Christmas with my parents this past weekend. So cool. I have the new headset that you left there for me. It's kind of like it's a post office box for me. Also made some of the same curry that you brought Mom. I made a batch of it for the family Saturday night, and mine wasn't quite as good as what you brought, but there was a lot more of it. So yeah, I made up for it in volume. Beyond that, I did something that I was pretty pleased about, and it's going to sound really stupid. I wrote a really small utility app for myself in Node, and all it does is it creates a bunch of links for me to use as shortcuts in Windows, and it's different on different machines. And I've got it where I can detect which machine it is, figure out where the root directory of all my stuff is, and it'll go out and dynamically build the links and put them in a location, and then I've just got to point a toolbar at it. And the thing is I spent like an hour trying to figure out how to create shortcuts in .NET Core to the degree that I wanted to do. So like I have some customizations and stuff like that, and finally gave up and then switched over to Node, and I was done in 30 minutes.
Wow.
Yeah. And you think about, I've been using .NET since 2002, and I just did something faster in Node. And I'm pretty pleased with that. I mean, it's a little dinky app, and it just kind of handles a really small use case for me that gets rid of irritation, which, I mean, you know how fast I code when I'm irritated. So, that did play into it, but I don't know. It's pretty cool. So how about you?
So I have been fighting dependency injection containers.
Yeah, I saw those emails or not emails, the messages.
Yeah. I had it working, and I did realize I told you that it was working with the MVC controllers. I was wrong. My unit tests were working. I hadn't been going through the controller doing integration testing yet. I was just doing testing through a web API. And so I still haven't been able to get the dependency injection to work with an MVC controller. So I found a workaround. I just changed that controller over to a web API controller. Tricky, but it was possible since I'm not returning any views. It was just annoying. Now, really what I did is I had to get this thing working so other people could use it, because we've got another issue down the pipe that we've got to figure out. But it may come back to haunt me in a few months when I get to another part where I have to return something that's not like a string or JSON object. So
I think with most of the dependency injection containers, they actually have a piece that makes them work with .NET's, kind of built-in stuff.
Oh, yeah, I tried. Everything I looked for told me, here's how to get it to work with Web API because it will work with MVC. I'm like, but that's not my problem. My problem is it's working with Web API, but it's not working with MVC.
Yeah. I find it really frustrating to set up a new .NET project, because I did that this weekend too, just playing around. And I don't know. I don't know why it feels like it's a lot harder than it has to be.
Yeah. And what's funny is if I could do .NET Core, this wouldn't have been a problem. It's because I have to do .NET Framework on this one.
Yeah.
And so because of the SOAP protocols that are non-existent in .NET Core. And I'm like, that's nice that you guys want to move everything over to rest, but not everybody is doing that. And sometimes you got to talk to a third party who doesn't have that option and who says they don't ever plan on building that option.
Yeah.
You know, if I were a Java developer, they have a REST API for Java, but that talks to some Java stuff. But I'm not a Java developer, so there's that.
Yeah, that's got to be
But
frustrating.
then Windows forced an update while my laptop was shut down. Like literally turned it on. It's been off for a few days. I was out of town this past weekend and spent most of Monday evening cleaning, so I hadn't been on it. And yeah, I turned it on. Let me help you set up Windows.
Yeah, I did get that. That was this weekend. That I got hit
Yeah.
with that over the weekend. Okay.
Yeah.
I thought you meant like today, a forced update. And I was like, no.
No, I haven't been on. Yeah, I haven't been on my computer because I was out of town. So yeah. But you know, dude, Microsoft, that's not cool. My computer was shut off and they got in there and updated it.
Yeah, and I've had that problem too. And it's not, my concern with that is what happens when it's in a bag or somewhere that's not ventilated and it overheats and damages my laptop because they did that, right? Like, or starts a fire because it could legitimately be left somewhere that's maybe not the best place for it and really overheat and catch something on fire because I didn't think it was going to get turned on. Like it just seems really risky.
Yeah.
Why they would do that.
Mm-hmm. And then finally, it's just been a rough day, I guess. Spectrum has started becoming more like Comcast. They used to be pretty good, but now they're punishing customers for staying with them. And I called and they refused to rectify the situation. So I'm looking at other internet options out where I live. And we tell you, it's pretty sparse.
Yeah.
It is pretty much anywhere you go, though. Like, there's like, what's the point of having anti-monopoly laws when they don't apply?
Yeah.
But, I'm not going to get into that. So speaking of money, it can be frustrating and hard to deal with. But having a good certified financial planner on your side can help you with that. Lucas Casares owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like CDP, he focuses on helping you to not only establish a real plan, but also to take action so that you can live your best life. These two things fit together, right? Like what we're trying to do with developers here to get people where they have a better career and they have a trajectory that is sustainable and that gets them where they want to go. He does that with finances.
Yeah. And he has a unique pricing model. I've taken a look at it. Working with a financial planner is expensive. And we talked to Lucas, I think it was just last week for you guys, a few weeks ago for us. Will gave me a funny look and I'm like, all right, dude, I'm trying to flow here. Anyway, yeah, it can be expensive, but the value you get is absolutely worth it. The big thing about Lucas is that he is a fiduciary for his clients.
Yeah. And the point of him being a fiduciary means that he's not here to sell you a product, but to help guide you to a better financial situation. So he's not a salesman.
Yeah. And you can find some fun free resources and learn more about what he does at levelupfinancialplanning.com.
So in other news, we've got 2 new patrons.
Yeah, we want to give a big shout out and thank you to Kim and Francois, who joined us on Patreon and are helping support the podcast and helping us to deliver content to you guys. I mean, it's really awesome. It really helps us out a lot. Thank you guys.
Principles are an important thing. However, like a lot of other situations where principles are important, the principles of object-oriented programming occasionally require a little extra thought to implement when things get difficult. In particular, as your team grows, a lot of the things that you learn early on in OOP have to be adjusted to the reality of working in a larger team. While this isn't exactly a compromise of the principles of OOP, it is definitely a learning experience that will deepen your understanding of proper practices, usually after it frustrates the crap out of you.
Like an object model with a lot of different types, the interactions of a large team become more complex in a thoroughly non-linear fashion. Eventually, this complexity will require you to adjust the way you interact with the system, or else the whole thing can come grinding to a halt. If you don't address this and adjust the way you interact, the resulting stability issues will make it hard to get anything done. For interpersonal interactions, most organizations will divide responsibility among a set of smaller teams, basically limiting the number of challenging interactions. In an object-oriented code base, a similar approach is applied, but you'll find that it doesn't tend to always work the way you expect. Managing large teams of people who are working on the same code base a lot of times can result in some interesting problems, to say the least.
In this episode, we're going to discuss how some of the object-oriented principles we all know and love tend to get bent a little bit as teams grow in size. While this doesn't mean that object-oriented principles are completely abandoned, they often are deprioritized a bit in favor of things that can keep the team working over the short term. Now, a lot of the stuff we're going to talk about in this episode is also true if you have a large team of procedural developers or a large team of functional developers. However, it seems like they adjust a little bit better.
What about a large team of function level developers?
Yeah.
Remember a few weeks back?
Yeah. I think the thing with OOP is that it fits a mental model that most people can quickly kind of pick up, and they take it and run with it and apply it everywhere, and it becomes like a golden hammer. Plus, it's really common. And so
what's funny to me is I've talked to developers who have been around as long as Will or even longer who came up in an era that wasn't predominantly OOP. And they talked about how they had to change the way they thought about things to work with OOP. Whereas when I got back into it, I should say, that was the predominant thing. And so it was just easy because everything was OOP. Every example, all the conversations were around it. So you were just in the environment long enough, you started absorbing and understanding things.
Yeah. And I guess it's a characteristic that I've noticed with people that, their worldview is predominantly OOP, that they have a harder time adjusting to being on a large team and having to deal with principles getting bent in a way that procedural developers flat out don't care. As far as I've been able to determine, they want some structure, but they're not wound around things. And I think functional developers tend to be protected a little bit because things are composed instead of inherited. And so they don't have these same characteristics. So I guess we should talk first about the basic reasons for team and code base growth, just to level set everybody. Because it really goes without saying that the reason you tend to see large teams working on large code bases is because there is an economic value in doing so.
Yeah. It's not likely that a large team will stay employed very long if this isn't the case.
Although there's cases where that's not true, but we won't go there.
Well, yeah.
I've seen them stay employed longer than you would expect.
Now that makes sense. I can totally see that. Also, given this economic value, larger teams and code bases have to be able to prove their value on a regular basis, or they risk being cut. And what this means is that deliverables have to be met and systems have to remain stable. Because, if you think about it, you have a large team, you can cut some of the fat, I guess, off the team and still continue to function and work. You have a small team, you cut one developer, you guys are suffering. I know, because I've been on a small team where that happened.
There's a difference between cutting the fat and amputation.
Yeah. And what tends to do is the long-term effect of it is that schedule and feature set pressure is placed on the team.
Yeah, right at the same time as the growth of the team and the growth of interactions makes those things harder to achieve. So any complex system that works tends to evolve from a simple system over time. This additional complexity is often required to deal with hidden complexity in what reality actually is versus your model of reality. This is also, by the way, why we do OOP in a lot of cases, is so that we can kind of firewall off little areas of complexity instead of it being a big mass.
Yeah.
But this added complexity tends to require more and more people to deal with it over time.
So, getting into it, the first thing we're going to talk about is Yagni. And that is often provably false.
Yeah, in a large team. Now, I know somebody's head just exploded. Put the pieces back together because we've got a reason we're saying this. Yagni means you ain't going to need it. In general, it's a good rule, and it suggests that you shouldn't gold plate your code for future scenarios that you can envision. But, those scenarios haven't come into scope yet. This really meshes well with the agile notion that you only build the things that you need and that you don't borrow trouble from the future. However, in a bigger team, that doesn't work quite as well as you want. In fact, it breaks down pretty bad. Because if something is needed in the near term, it can be harder to tell how soon it will be needed because you have shifting priorities and all that kind of stuff. So you may go, hey, this thing's 3 months out. Well, you may need to build it now because next week it may be a week out.
Yeah.
Just because the scale of things.
The other thing too is that, and this is, something that I ran into with the whole DI stuff, is it was blocking the rest of my team. Now it's not a big team, but it was still blocking the rest of them from moving forward with a part of what we're building. Is that, big parts of your team can be blocked from getting their work done if that feature isn't implemented. So it may not be needed for 3 months at the user level, but the other teams may need that to build their parts that are also needed in 3 months.
Yeah. For instance, let's say you have a screen that you're filling in and the next step is something that edits past there. Well, if you can't get past there, that other part may be hard to build. Or let's say you're adding an enterprise message bus to your application, right? In a small team, you might simply add it and migrate existing code to take advantage of it, merging it into the main branch at a reasonably safe time. Well, in a larger team, there might not ever be a safe time to merge this in where it doesn't disrupt at least some other parts of the team. Management's going to have to plan the rollout of these kind of critical features and the projects that need them in such a way that they clear up the calendar for releasing them. So the developers don't have the control that we're accustomed to having, and management typically doesn't have the foresight that they would like to have.
Yeah. And there's an interesting thing about the whole, I've run into this with Yagni where it was I was talking to someone, a junior developer, and they were telling me, oh, well, I'm not going to need that. And I was like, yes, you are. If you look at your backlog, that's coming up in 2 sprints. So you want to build in such a way that you're ready for it and you don't hit that and go, oh no, I have to go rewrite this other code to make this work. Yeah. Versus, that's coming up in two sprints. You don't have to go build the thing now. You see what I'm saying? It's there's a little bit of a difference here in planning and executing.
Yeah, it's like you're bringing a little bit of waterfall back into Agile because you're at a scale where you have to think ahead more than you would when you're developing an MVP.
Right.
So the next thing that comes up is that you'll find that your development practices start to be driven by the potential for file conflicts rather than, oh, this is a good idea.
Yeah, if you only have a couple of people working on a team, merge conflicts when checking into source control are pretty rare, especially if you are keeping your code clean and you're actually following object-oriented principles.
But if you have 30 people working on the same code base, often with completely different deadlines, different expectations, different features they're rolling out, potentially different management structures above them. I've worked on teams like that where you've had 2 or 3 main managers and they're managing teams that are working on the same code base and they're intertangled. That's not real bright, by the way. But it's I've seen it and it's it's a thing to behold. If you don't want to work hard, that's a great place to work because you'll be blocked all the time. But what happens in these kind of situations is that you'll get merge conflicts and you'll get big ones, especially when somebody does a refactor. And if you just rename something and you touch 30 files, I did that the other day. It was awful trying to merge all that. If these conflicts happen deep inside the system, this can result in a lot of work across all the teams in testing for regressions, especially if they've got different areas of responsibility, but they use the same code.
Yeah.
So we actually had this at work fairly recently. We had 3 teams and now we've got 4 because this was like the day before it switched over. And one of, we're in the meeting and, my team lead wasn't there. So I had to go and represent, which is probably not a good thing from me representing anything. But one of the other teams was like, oh, we got to build this service to handle this because we've been handling it in our little command handler type stuff. And that logic needs to be in other places. And before I could say anything, the other team lead goes, hey, we've got to have that too. We were starting on building it. And they're going back and forth. They're like, well, if 2 teams are trying to do it, and I said, that's 3 because mine is 2. Like we have a big problem. And the thing about it is let's say that we all 3 build that service. Well, how do we merge that?
Yeah.
You can't. You build 3 separate ones and then you try to merge it later in a separate story so that you can still roll functionality out. And if you tell an OOP purist that you're doing that, they're going to hit the roof until they've been in this situation where it's like, yeah, I've got a deliverable, by the end of the first week of January. This has to happen.
Yeah. I can totally see that going on, especially with that large of a team. Next, deprecation of old code can be a lot trickier when you have a larger team and a larger code base for that. Getting rid of obsolete code that is deep within your system is easier with a small team. You can a lot of times just remove the code without talking to too many people. And usually you can time its release so that you don't cause a lot of major problems or any problems for your other team member. However, with a larger team, yeah, there's going to be a number of long-lived code branches in the source control that use the code you're wanting to get rid of. I will say this is one thing I do like about .NET, at least with the Visual Studio IDE, is when you're going in, you can look at the references and go, all right, who is calling this? And I have used that when I've gone back into older code and like, I thought I removed that. Am I even using it? And I'll go in, it's like, oh no, not using it at all. Or you go in and someone else has been in the code base and they didn't tell you, and you're like, what's going on here? And you can use the reference to figure out what they're doing. So
yeah, well, and I've got a point that I'll bring up about that here in a bit, but yeah, you do kind of find in larger systems that you don't know all the ways in which a particular piece of code is being used. Like you don't know the flow anymore. Larger systems are also more likely to use reusable component libraries that are shared. So like an NPM package or a NuGet package or something that you're exporting and somebody across the cube farm is using it on something else and you don't know because it just goes into a repository. So that will bite you. The other thing is when you get a bigger code base, a lot of times you'll see a fair bit of meta programming in there, especially during startup to wire crap up. And so your Visual Studio display, for instance, may say, hey, nothing references this, but it's actually found by reflection and invoked dynamically. And I've been burned by that one a few times too, where it's like, oh, I can remove this. Nothing references it. And oh yeah, it's actually critical. And it's like the 3rd line of startup.cs uses it. Like I can literally get the error message from it blowing up and nothing else. So that will get you quite a bit. And it's also kind of tricky a lot of times to regression test in a timely fashion to determine whether a deep change has broken a large piece of the system. Even something like a rename can do that potentially if you've got that metaprogramming stuff mixed in with your regular execution.
Yeah. Yeah, you're going to likely need to adopt a staged approach to removing large chunks of code. basically allowing other parts of the team to remove or adjust references until something can be safely removed. I mean, in a way, you do this on a smaller team too. It's just with a larger team. Like with a smaller team, it's you and the other developer or two get together and talk about it and do it at the same time. In a larger team, it's a process.
Yeah. And, as your system gets more complex, your deprecation strategy might also need to include the use of feature flags. In fact, I would say that it probably should, so
Mm-hmm.
that you can quickly switch between the older and newer implementations. So you actually do it in parallel and then start gradually flipping feature flags over to
Yeah.
turn it on. That way, if something blows up, you can recover instead of, oh, well, we're just up the creek.
Mm-hmm. Yeah.
You do have to bear in mind that your QA folks also have to, do major regression testing, and that they're part of the team too. And they may be relying on pieces of it to behave in certain ways. And you didn't think about it because they're calling some endpoint and they get a JSON payload back, and then they test and they do other stuff with that. And if you change something, you have no idea.
Yeah. Next, code duplication can be your friend.
I like how you reworded that. I said it could save your hind end. Uh, so the usual rule that most of us follow is to allow code to be duplicated up to 2 or 3 times before you refactor out similar functionality. That way you can make sure that it's actually the same functionality before you try to abstract too early.
Mm-hmm.
However, in this situation, you may want to take that advice with a grain of salt, due to the larger team. For the same reasons that you can't easily remove deprecated code quickly, you probably also can't drastically refactor duplicate code, because again, a refactor to remove duplication is actually a removal of those other pieces of code.
Yeah.
Furthermore, you might not want to do this, at least without, staging it in the same way.
Mm-hmm. It's interesting going back to Yagni. This is a time where, like, you can kind of plan out a little bit ahead. For example, I was working on something. Mind you, this is a small team, 2 API developers and 1 UI developer, so not a big team at all. But I was working on something, and I realized, hey, I'm using this exact same code in 2 places within this one endpoint, and I'm going to do very similar things in 2 other endpoints that are going to use basically the same code. And I'm like, all right, yeah, I'm only working on this one for this sprint, but I can go ahead and extract this out because I know what's coming up.
Right.
I know we're going to have this feature. Like, this is going to be one of the things that's coming up, and it's going to need this stuff because it's the difference between upload and update in a file system. Uploading a new file versus updating an existing file. And it's like, all right, they're both going to use the same process to, get the file from the request and stuff like that. So why write that 6 times, basically?
Been there and done that. Remember that if you do refactor to remove duplication, that you're going to increase the surface area that needs to be addressed by testing for regressions. Essentially, you might not want to do it all at once, simply because it makes it easier to troubleshoot if any production issues come up. So it may be, hey, here's the new way we're getting rid of this duplication. We're not getting rid of it yet, because when this thing rolls to production, if it blows up, it's only going to blow up in this one spot rather than 15 disparate places and have everybody running around with their hair on fire.
No.
Now, I built a out-of-band job processing service at a previous job, and we rolled it all out at once. We had kind of a way of doing it before that was like a database as a message queue, kind of like, don't do this kind of thing, and it worked-ish.
Okay.
And I got tired of it because, the ish part of it, working-ish, didn't really work all that well. And we rolled it all out at once.
So it was more ish than working.
Yeah. And when we rolled it out, it worked great until 2:00 in the morning, about 2 months later, when it got under load and it had some performance issues. If I had done this gradually, we would have stepped up. And when that first event occurred, the thing that I had to replace it for was that, the thing that actually broke 2 months later. That would have been probably the only thing that blew up.
Yeah.
And so you got to learn to stage those things, even if it's like, hey, this is a good idea. It's not a good idea all at once. Like drinking water is a good idea. Drinking an ocean is not.
Yeah, I can tell you, Amanda's dog has learned that the hard way.
It seems like that's the way dogs learn.
Yeah, she took him to visit family over the holidays, and poor dog, he first time in the ocean, he loved it, had a blast, but he drank a little too much ocean water and got himself sick.
Yep.
And so he's starting to feel better. Well, by the time you guys listen to this, he'll be fine. He's feeling better now, a week later. But it's like that, and yeah, like it makes sense. It reminds me also of like the whole thing with any type of, like, people talk about coding boot camps being like drinking from a fire hose, of just like so much knowledge. You just try to get as much as you can from it. Yeah. So like I can see that with it's better to break it down and do that.
So the next thing that happens to OOP systems is that inheritance gets replaced by genetic disease. Object inheritance is one way that duplication gets removed in systems that are built using OOP. Unless you carefully manage it, this approach to removing duplication can very quickly become brittle. By the way, this is why a lot of people do things by composition instead of by inheritance, because it gets rid of that. If your team's been around long enough and it's large enough and it has a large enough code base, it's almost certain that the ugliest area in your code base is hard to change due to an inheritance hierarchy having been built around it, often with clever little hacks to support edge cases, essentially.
Yeah, I can see that with a larger code base.
I have seen that. I wrote it.
Yeah, thankfully, most of the stuff I've worked with has been smaller code bases where the inheritance hierarchy was pretty simple. There for about a year, I'm calling that my mid-level developer year, because I got super complex in the way I was writing code. And honestly, because I didn't have a senior developer looking over my shoulder going, hey, maybe you shouldn't do that. Maybe, I learned very quickly that, like, why that doesn't work out and why you don't want to be too complex. Sometimes now, like, I'm still, I'm still learning a lot. And so sometimes now I'll write something complex to figure out, like, oh, hey, this is this really cool thing. And then I'll come in and simplify it. But I did that a few times with even smaller code bases where I had like these complex inheritance hierarchies. And then I had to go change something. I'm like, this is such a...
Yeah. Well, and the larger your team is, the greater the odds are that there's a mid-level developer doing that right now, or that did it a year ago and doesn't work here anymore.
Oh, yeah, I can see that.
Where you can't even follow their reasoning. And so basically inheritance starts to hurt. With few exceptions, most concerns that can be addressed by inheritance are better suited to being addressed using composition, doing code generation, possibly doing aspect-oriented, programming, or nearly any other approach. Just because you don't want to tie everything to a base and reuse something in a case where it's really not reusable.
Yeah. Now, bear in mind that advice given earlier about refactoring obsolete code and duplication both may be necessary to get control of deeply nested inheritance hierarchies without disrupting the rest of the team or causing a lot of extra testing.
Right. So you might just take that method out of the base class and paste it somewhere and go from there. And sometimes that can be the best way forward. Mm-hmm. Now, you don't want to leave it that way, right? Like all this stuff is like, you've got to understand that this is a transition phase between the problem and the solution, not this is the solution.
Yeah, that's like, well, I'm just going to give you guys a quick example here. Again, not on a big team, but I spent about 2 days. Most people were out the week of Christmas, and I ran into a problem I couldn't, like, I needed another team to solve. because we're working with their software, and I'm like, all right, well, I can't solve this until they're back from Christmas, so I'm going to work on a different part of this. And it was the authentication piece, where we're taking in the authentication and then using that to then establish the connection and authenticate in that other piece. And at first, I was like, all right, I built it, I got it working, I figured it out at the method level. It's like you call the endpoint and it's got that in there. And I was like, all right, I don't want to have to like write this or even extract it out and still have to call it from every single endpoint. So I wonder if I can move it up the HTTP pipeline.
Yeah.
So I start moving it up the pipeline and playing around with because part of it is like it's establishing this connection with the other, and you need to persist that object. So I'm trying to be like, all right, where in the pipeline does the dependency injector sit so that I can do it after that, but before the controller gets built. And oh my goodness, it was complex to say the least. And you know what I ended up doing after spending about a day and a half on it? Going, you know what? I work with a guy who basically wrote his own single sign-on and really knows the stuff very well. I'm just going to put it at the method level, and when we hit the next one,
then have him fix it.
Have him fix it.
Yeah.
Because he knows that stuff really well, and I will go in and I will learn from him.
Yeah.
Because I know what I've been working with well enough to go, hey, here it is. What would you do? And sometimes you got to do that. Sometimes you got to go, you know what? I can't do the best design, the best thing for this. So sorry, I got off on a...
Well, that leads perfectly into the next point, because as your team scales, you are going to have knowledge gaps and silos, no matter what you do. And basically, if the team gets large enough, there's going to be some chunk of the team that knows a particular part of the system really well, and the other teams are not going to know.
Mm-hmm.
And it doesn't matter if you try to avoid it. These silos will manifest in wildly different approaches being used to similar code in disparate parts of the system as well. So like you have to touch some code that some other part of the team that you don't really interact with much, if they do that, you go in there and it's completely different. So your team might use inheritance, theirs might use middleware, right? To handle the same kind of problems. And so you'll run into that. Now, the other thing is that these knowledge silos can result in some interesting uses of existing code, to say the very least. You may well find that something you built for a single purpose a year ago gets used in a situation you never expected, in a way you never intended, and in a way that only fails in a really subtle manner.
Sounds like experience.
That is exactly what that is. For both ends of it. Because I've also used things in an interesting way where you show it to the more senior developer and they look at you and they go, that's different. And that's when you know that you're in a bad spot. Basically the thing is as the team grows, you have to be more comfortable with having incomplete knowledge and making decisions based on it.
Yeah. When you find problems like this, you can't really fix them immediately. And you kind of have to follow the same deprecation approaches that we've already talked about in this episode. Also, spend some time trying to determine if the new use case is one you want to support.
Yeah, just because somebody on your team uses your code in a weird way does not mean that you have to support it.
Yeah.
You may go, hey, look, this is a real bad idea and you need to do it a different way.
Mm-hmm.
I'm not going to help you make it worse, essentially. Removing knowledge silos is something that you might try to do on a smaller team. On a larger team, you just have to accept that they're going to be there and you act accordingly. And this can require that you spend a lot more time making sure that documentation is in order, as well as limiting the types of situations that your components are designed to handle in order to make it less likely that they will be misused. By the way, this is kind of one of the core things under domain-driven design. That's why they do that. It's because as it scales, you got to go, hey, I got to keep people from doing dumb stuff that puts my objects in an inconsistent state.
Yeah, that makes sense. And there's a lot of things that you can get away with on a smaller team. The thing with a larger team and with knowledge silos is you don't, as you don't want a very narrow silo. You don't want one person being the only one who knows it.
Or one group that's likely to get fired together.
Yeah. Yeah. You want to distribute that knowledge a little bit, but it doesn't mean everyone on the team is able to do everything.
Right.
Yeah. You'll also note how this doesn't perfectly match the way that a lot of object-oriented based systems see reusable components. I mean, the fact is that you are safer in larger systems having more components that each cover fewer use cases.
Right. Because it's just a failover mechanism for, okay, this guy screwed up, but he only screwed up this one place.
Yeah. I mean, look at what happened here in Nashville Christmas.
Yeah. With the bombing, right? Like it hit a data center and the data center had backup generators, but they were natural gas, apparently. And yeah, all the things were shut down. Like cell phone services messed up. You know how many people were traveling that morning and didn't have cell phones?
Mm-hmm.
And how many people probably are completely reliant on Google Maps, for instance?
Yeah. Or the fact that many counties out used that service for 911.
Yeah.
Like even way out where I live, they were posting all over Facebook to call the police station directly instead of using 911.
Yeah. Thankfully, no accidents ever happen on Christmas. So yeah. And it's one of those things like in complex systems that is really hard to predict how something will fail, but you want to have, if you're going to have a total system failure, you want it to require quite a few failures preceding it.
And I will be honest, I gotta say I'm impressed with AT&T. They got services. I mean, they're still not perfect, but they got them back up a lot faster than I expected them.
Yeah.
So while it took it out for a while, they did jump on it and did a good job there.
So speaking of doing a good job and being a good steward of the code that you write and trying to keep it clean in a large team, I'm going to tell you right now that either you'll have the lava flow anti-pattern in your code. That's where, we found a better approach. We did it on part of the code base. Oh, we found something even better than that. We did it on another part of the code base where there's 3 or 4 different layers of increasingly crappy code the further down you dig. That's the lava flow pattern. The thing is, you're going to have that on a large team or you're going to miss deadlines.
Yeah.
And refactoring on large teams is tricky because, we talked about that basically every point in this outline. And as your team's practices evolve, you're going to find that previous approaches are insufficient, or you get somebody that comes up with a better one, or technology changes, or whatever. And this happens on any team that has even a tiny amount of introspection, and it shouldn't surprise you when it happens in yours. If it doesn't happen in yours, then you're in a bad spot.
Yeah. As you learn more about the best way to approach building systems, you'll a lot of times find that newer code implements newer paradigms, while slightly older code implements slightly older paradigms. And really old code implements paradigms. Or really old paradigms.
Here we go.
When you said paradigms that many times, I was going to have to do it.
Yeah.
No, like you were saying that, and I'm just like over here shaking my head because I know of some code, like one particular application where I did try to go back and get all of it, like to refactor everything, but there's like 1 or 2 places that's very rarely hit that I missed, and I've gone back into it and I'm like, oh yeah, I know what I was going through when I wrote that. Let me fix this really quickly. And then you go in a little bit later and you find something older. What I find most frustrating though is when you go in to it and suddenly there's something completely out of place and you're like, who's been in here?
Yeah. And on a team of 30 people over 5 years, I mean, you'll see stuff like, I worked with a guy that was For some reason, we didn't realize it. I think largely because he mostly worked at home, but he was a functioning alcoholic and he
Yeah.
drank all day when he coded. And some of the code he wrote was brilliant, and some of it was clearly later in the day. And we found that stuff, 3 or 4 years later. The guy ended up
Hmm.
dying from
Oh, wow.
alcohol, so he's pretty bad off. But I mean, we found stuff years later, and
Oh, I
it
bet.
hadn't
Yeah.
been touched.
Especially if it's in a more obscure area, or if it only fails under very weird circumstances and those haven't come up.
Or
Um,
he could write extraordinarily stable absolute crap.
yeah. I've seen
Which
that.
is exactly where you're looking at it, you're going, I can't understand how this works at all. And it's been up for 6 years and it's never had a problem.
Yeah.
And I'm just going in here to add a feature and I can't.
Yeah.
Yeah. So you'll get a lava flow type pattern and you probably want to get rid of it, but you can't really do it very quickly. You're going to have to find peace with keeping things around, even though it's not optimal, because deadlines still have to be hit, or your whole team is looking for new work and you don't have the lava flow pattern anymore because you don't have employment.
Yeah. As a result, you might find that you have to slowly refactor those piece by piece. And that's what I have done in the applications where I realized I did that. It's a learning thing, it's a growth thing, and like now, even if I found a better way of doing something, I'm not going to implement that in an existing development. I might try it on something new.
Right.
And so, but yeah, next, app scaling problems will start to impact testability, and then we're going to require duplication. I mean, if your application is large with a large team, it's likely to have some scaling issues. I mean, even if you don't have a large team, it's going to have scaling issues. Just that's reality. These issues will also likely be different in different parts of the application. You may find that adjusting shared code for one use case ruins scalability for another use case.
Yeah. So we had an example like this where we had a repository class that was deep loading stuff. Essentially, you could say, hey, give me this set of things and also give me the child elements under it. And it had a shared piece in there essentially because it's building up, a link expression to get all that stuff. And we had multiple things calling into it. Well, one thing had to have all this stuff deep loaded because it's dealing with a single element and all the crap under it. That element is a transaction. We have an
Yeah.
online giving system, for religious organizations. So when somebody calls that same method with 1,000 transactions or with all the transactions for an organization over a year, very bad things happen to good people. And so we had to break it apart and go, okay, these, even though we don't want to have duplication, these are actually two disparate use cases now.
Yeah.
That use the same code. And it hurt. Duplication is not ideal, but you'll find in the short term that the best choice is to actually make duplicate code and then adjust the pieces according to the new use cases versus what you thought they were a while back. Code reuse is great, but a lot of times it really it loses utility over time because the consuming code evolves.
Yeah. And I mean, this is one of those things where the idea is to reduce the work. And when you're doing, and I've looked at it before where I've gone, hey, how much work is it to make this work with what I've got versus to duplicate it and make those changes within the code? And sometimes it's less work to just duplicate it. Like even in the long run, it's less work to duplicate it because the use cases are diverging. And eventually, like, that duplication is no longer a duplication because while it's doing a similar thing, it's not doing the same thing.
Yeah. I mean, it's like your code is built to handle a population of use cases, and now you have genetic divergence.
Yeah.
And if you don't accept that, one of them is going to die, and probably both.
Right. Right. And basically, what I'm getting at is to only reuse code when it makes sense, you know, because if it's going to be more work to try and keep the reusable code or to access the reusable code, then it's not worth it. For example, I had a method that was basically creating an error result. And at first, it was just, I wanted it to just create a 400 bad request and pass it back. And then I had a use case where I'm like, hey, I needed to send back an unauthorized. Well, I can adjust for that. And like a couple more times down the line, and I'm like, all right, I rewrote the reusable code, but I had to like refactor all those places. And I'm like, would it have just been easier to have written one separate for that? And then I realized that I could pass in a null value and have it set the value if it was null. And I'm like, well, that was dumb of me. So you know how it
Yeah.
is. You like in C sharp, you just in the parameter you say this, and then you can equal that. And so if you pass in a null for it, it sets it to that. So I was like,
Yeah.
I did all this work, and then I realized I remembered that, and I'm like, well, I feel dumb.
You kind of threw me for a minute because I took what you said as saying this equal to null, and I'm like, that's the most Zen C# coding ever. It's really like the more you think about it, the weirder that gets. Yeah. So basically, yeah, like you said, you only reuse code as long as it makes sense, and when it stops, you stop because code has to be mutable or it
Yeah.
doesn't have value. Speaking of code being mutable, standards compliance is something you're going to have to think about. And it's going to have to be tooling enforced instead of by way of code review or we just trust you, bro.
Yeah. While code reviews are great for reducing knowledge silos and helping to enforce code standards, as the team gets larger, they become less and less effective, and enforcement breaks down. Instead, code reviews will evolve to becoming a way to educate the team and remove silos, with standards being enforced by tooling.
Yeah. Standards compliance being enforced by tooling is going to also start to change the way that design happens. And this is something to be aware of in larger teams. Like if you have XML comments required in .NET. Like that's the bane of my existence at my work. Like I'll start a new file and I actually have a notepad file open with all of the stuff to turn all that crap off that I paste it over and I do my work and then I remove those and then fix it because we have XML comments and a bunch of other stuff required. And it's like, I need to play with the code first before I deal with you breaking the compilation for standards compliance. But we have to tooling enforce it. And I understand why it's there. So I found a way around it temporarily.
You would.
Yeah, because what it does is it damages your ability to refactor. So for instance, okay, I'm making another method that takes this part out. I'm extracting a method, extract method refactor. Well, now I've got to write XML comments for all this stuff. I've got all these other things in the mix. I've got to describe all these parameters when really what I wanted to do is just break it off. Yeah. And so you'll see that start to shape your design and it does weird stuff, I guess is the best way to put it. So yeah, it's just something to be aware of and to be aware that it changes your design where you don't do things that maybe you should because they're now a lot more work. The equation changes. So guys, OOP can be a useful paradigm when building an application. However, the principles of OOP, as you learn them from a textbook or a starter article, are not necessarily the way things get implemented in messy, real-world scenarios with lots of other people. As your team grows, team dynamics and interactions tend to force some changes in how code is written, designed, tested, and managed. While textbooks will teach you general principles in a fairly clear-cut manner, the application of those principles in the real world, especially on a larger team, is probably not going to be so clear-cut. And that pretty much wraps us up. Beach, what do you have for us this week for Tricks of the Trade?
So I talked to you guys about the issues I had with the dependency injector, and also like I kind of mentioned a few different things that I've been dealing with the past couple of weeks, or like over the holidays when most people took off. I worked except for on the holidays. And today I got an email asking me about some documentation on, it's a small project. It was one of the things, it was very, very small, 2 controllers, like 1 or 2 endpoints each, very, very straightforward, but high profile kind of thing. So I was asked about documentation on it, and I went to look at the code because I was like, I document in the code, XML documentation. And when I got in there, I saw a few things. I'm like, oh, I thought I cleaned that up. Oops. And so I told the guy, I was like, hey, it's just the XML documentation. It's in the code. I was like, there's a few things I need to clean up though. So I'm going to work on that when I have some free time. But that, and then the things I was talking about with the DI issues, where I just had to go, all right, I'm going to kind of push this off because I have to get it working now. It seems to be a lot of the theme of this episode, which is hilarious because I thought of this Tricks of the Trade before I read the episode. Yep. So you can see where our minds are. It's funny how it's on the same page there. But the episode, we've talked about this a lot too. I know in the show we talk about designing your code and using patterns, but sometimes you have to get things working and worry about refining it later. Sometimes like what happened to me a couple of times recently was, hey, I want to make this more reusable, but I don't have the time now to figure that out. So I'm going to build it to work and then put that into a place where I have more time. The tricky part is actually making the time to come back and refine. It can be easy to forget or get busy on another project or another area of the code and never return to clean it up or refine the thing once you got it working. Like that small project I was talking about, I built it and I moved on, and honestly forgot that there was a few things that I still needed to do to just sort of refine, like remove code that's not being used, that sort of stuff. What you have to do is find what works for you to keep track of things that need refining. I have my notebook, and I usually put to-dos in the code. Honestly, I think if it hadn't been for all the craziness, I probably would have remembered it on that small one. But, life has been interesting this past year. So, and it's going to be different for you to find what works for you. But you just got to find what you can do to help you set aside time to remember to go back and refine the things that you do. Because few things are as frustrating as going back into code that you wrote a few months ago and seeing a mess of things that you forgot to clean up. And remembering, I was supposed to clean that up back then. Now I got to get back in that mindset. I got to remember what I was thinking then and why I did things the way I did them. Yeah, it's very frustrating. So that's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.